Yeah, so we will cover here the alarm processing, how the alarm flows in a trail on OTN network which is having GFP-T framing. So it is basically used for 1G trails, 1G Ethernet trails. And the scenario you can consider that there are two sites, and each minimum consists of a tributary board and a line board. And there are scenarios where basically we will cover where no ALS is enabled and no LPT is open. So ALS is automatic laser shutdown, which is used to avoid the human hazards because of the laser utilization. And LPT does the similar function, but other than the laser hazard, the main purpose of LPT link pass through is to inform the distant end uh, at the Ethernet layer that there is a problem at some end, and then that should go off, because mostly the use of LPT is to give the information to the distant end interface, and if it is router, so that it can come to know and it can change the routing and update the routing table. So this is the scenario in front of you. So if site A and site B, so from site A side we get R loss. So if there is a problem of fiber cut, card issues from the client, and there's maybe power failure of the equipment at client, so you get R loss. So received signal is lost, so loss of signal, that immediately trigger alarm through NMS and give R loss. And because this frame is GFP, it's an encapsulation. GFP is global framing procedure, which is used to encapsulate the different technology signals, and here it is Ethernet to OTN. So that wrapping does not allow any information to be opened at the line boards, because then line board only work as a transporter, so they do not understand the language of GFP, and they do not take any action in terms of reading the frame or taking any action based on any problem in the frame. So that goes end to end between two line boards seamlessly, transparently, and it is read at the point where this frame is understood, which is B end side tributary board. So if one side it is R loss, this will give a trigger alarm at Ethernet that remote signal failure, so RIMSF. And then further to the further end, it will give you the it will actually insert one 10 byte error code stream, and which is read by the B end client. So this client is a customer and equipment, or for this section this is the separate network. So that that 10 byte error code which has been inserted by B end tributary board is read as L sync, local sync, or L sync, link sync. Okay, the second scenario, if there is no issue between the client, site A side of client box and the receive port, then in this scenario, if there is a issue beyond that client A or A side client, which can be customer as well as any network of self, so if there is problem beyond that node which is not shown here, then he will give me this type of coding. So he will give 10 byte of fixed type of coding, which I will read as this client A will read as L sync, and at the B end the the consequence alarm will be the same, remote signal failure. So signal is failure. So if data cannot be transmitted, the end-to-end communication cannot happen, then it is remote signal failure. And then the consequence of further client is the same, because I would insert a 10-byte error code of fixed type which will be read L-sync. Okay, the third scenario is if there is still services are there, no problem between the client equipment at A end and site A equipment, and even there is no problem as such in terms of continuity, but there are bit errors. So bit errors, again the thing is that it is transparently transmitted including the tributary board.b end, and it will be handed over to the equipment of the B customer or B client. So if I get a error, this will be captured in terms of performance event, but there will not be any alarm, and that will go as a transparently to the distant side of this. So this is the very simple scenario where problem is at customer end or client end for this section. Okay, in this you can see that it is always shown left, but there can be similar scenario where the B end client, the tributary card, can get this R loss or L sync. The consequence alarm at A end then will be just opposite. Okay, so if there is a problem in B end here, then the R remote SF alarm will come here, R loss will come here. In the similar scenario where ALS and LPT is disabled, and what would be the alarm flow when there is a problem between the section, so between the line boards of OTN. So there will be problem, maybe fiber cut or other issues, which is clearly mentioned here. There are so many scenarios as such, but in summary we need to just understand that the problem between line boards is a service signal failure type or degrade type. So service signal failure type or service signal degrade type. So the signal failure type comes in where alarm ODU, in all the ODU have AIS, so all ones, so which means no traffic. So all ones is not the real traffic, so it is a signal failure. In terms of OCI, open connection indication, so at this line board, if it is received at B, means there is some connection in the trail is missing at site A. So OCI is also signal failure, and if you take some trail under maintenance, then also there will be problem, and because that will be tested by internal tester, or it will be forcibly deactivated or something, then you will have this type of lock alarm, so which is also showing the non-availability of the services. So that is also categorized in terms of signal failure. Then you would have OTU layer of AIS and loss of multi-frame, loss of frame. So the basic building block for the L2 any technology is frame. So if there is a loss in the frame or multi-frame, or there is AIS, all ones in the frame, that is also categorized into the same, because there cannot be any signal when these type of scenarios are present or these type of alarms are there. And one more is, which is conditional signal failure related problem, which is TTI mismatch. So trail trace identifiers are used to identify the continuity or to avoid any foreign signal, to avoid any alien signal. Sometime in the similar 48 fiber there can be multiple OTN networks of the self operator, or it may be of some other operator. So while the frame are, because they are ITUT standards, So frame is fine, so as per the frame there won't be any alarm, but to avoid that kind of scenario, you can put your identification per operator and you can enable this alarm. But in this scenario, if just finding out the mismatch is one thing and taking some action, because the scenario which I explained, that frame will be read correctly, but if it is not your frame, it is not required, or it is not recommended to read that frame, because that may create problem, because you would be also sending your frame to the operator or any other receive end. So if you enable the follow-up, that would become the signal failure, because that follow-up meaning is to bring down the network even if there is no problem in terms of continuity. So if frame mismatch in terms of TTI, then it is a conditional signal failure type. So this is same if in case of OTU layer, there is also trace identifier mismatch, which is TTI, trail trace identifier sent and received, and it is checked versus the what is expected. So same condition. So now I will go through that all type of signal failure type of alarms in back end, because it's a very critical thing detected at this B end. So in OTN, as there are a lot of overheads available in section monitoring bytes and path monitoring bytes, and in TCM also you can use the same thing, and there are options available to inform back. So inform back is there is a bit in SM, PM and TCM which becomes one and read by the backend, and that will give the BDI alarm, backward defect identification. So if BDI is here, means the downstream is receiving problem. So when we take the flow from site A to site B, so site A is upstream node and site B is downstream node, so BDI will be captured. So if alarms are at ODU layer, the BDI is informed at ODU layer, same layer. So it is K meaning is 2, then this will be ODU 2. So if there is a problem at ODU 2, the BDI will be ODU 2 PM BDI. If there is a problem at OTU layer, then the BDI will be at OTU layer as well as ODU layer, because if OTU is impacted, definitely ODU is going to be impacted. So there will be insertion, because there will be ODUK, let's say AIS, then the AIS is further inserted into ODU layer, and if the AIS is ODU layer, which makes the first type of scenarios, if I get ODU layer AIS, I have to inform back the same ODU as a BDI. So this is the this is combination of this OTU layer as well as the first ODU layer. In case of TIM mismatch at ODU layer, I will inform back the same way. OTU layer I will inform back and in the OTU layer. Okay, and OTU layer, this TIM is not like cascading kind of, which is the case here in the second scenario, that my OTUK AIS is again informed back to the ODU layer as well. So in summary, to say that if there is a signal failure alarm, the BDI will be at the same layer as well as at the below layers. So if there are further ODU K layers, K minus 1, like if it is ODU 4, then there will be BDI at ODU 4, and there will be BDI at ODU 2, there will be a BDI at ODU 3 if it is there, and ODU 0 or ODU flag, whatever layer are present in the trail as a part of ODU 4, all BDI will go back. Now this is the talk about the back side. Now in front side, in any signal failure type of alarms, the front side action will be the 10-byte error code. 10-byte error code will be inserted which was the case earlier. So 10 byte error code is a fixed combination of ones and zeros, and that the output of the client equipment would be read as a L-sync alarm. So I will insert a 10 byte error code, so L-sync. So in all the cases, and in case of team it is conditional, but if it is, the alarm will be L-sync in the forward direction client equipment end. Okay, now the second scenario is degrade. So if I get a degraded signal at the B end, so I would, that is degrade is based on those BIP bytes, BIP 8 bit interleave parity 8. There is a sequence of sending after calculation, and then it is read at the receive end. So based on the poison type or bus type, the alarm will be degrade or excessive. So this will be kind of what type of calculation you do, you define at your B end or A end. So we have to make sure that B and A, when they keep on changing. Just for study theory purpose, it look like A end and B end, but it is B to A is the same scenario. So then this alarm will be there, and then there will be bit errors will be just pass on. So this will be the scenario. So only in this case only you will see the alarms at ODU layers, but there will not be any alarm at client layer, the trail, which is the client trail. Okay, you can find out the bit error complained by the customer or another box, in this case client box, and there will be only degrade alarm. So degrade alarm, we need to take care of the degrade alarms similar to our signal failure alarm, because they can change into signal failure alarm if it is not attended. So this is PM byte. Similarly, the SM byte is also read with this ODU frame. This was ODU overhead, this is ODU overhead byte, but the decision and the calculation methods are same, and there will be these will be reported back. So ODU KPM remote and bit error performance event, this will be considered as captured in terms of performance event at ODU K layer as well as OTU K layer. So this completes the scenario of having issues beyond the network as well as inside the network, where LPT, link pass through, and ALS is disabled or not used. Okay, so now the scenario in terms of alarm remains the same if we use the ALS disabled and LPT enabled. So now this scenario 2 is LPT enabled. LPT enabled is basically used in Ethernet only. And one more thing, if you enable LPT, you cannot enable ALS. You can use them at once. So you cannot just ALS enable, LPT enable, cannot be the scenario. So LPT is mostly used in terms of Ethernet because it takes the action at both end. So the only thing is in ALS case, the action of laser shutting down will be taken at the distant end. So if the problem is at A end, the laser will be off at B end. That will be ALS. But in this case, it will be both sides. So in this case, this is LPT enabled case. So wherever the problem is between client and site A, the laser will go off both sides. So I get R loss, the alarm sequence will be the same, remote SF, but in this case I will just shut down the laser. So shutting down the laser avoid that situation of sending 10 byte code further, because I'm shutting down the laser, so there is no question of sending the 10 byte code. So then laser off, then it will be read as R loss. And if this sequence is there further, like there is a tributary and or this is a tributary of some other section, then this sequence keep on escalating the same way. And in the back end, like in this one also will go off. So if I have receive loss, then I don't send here as well in case of LPT, and I switch off the distance laser as well. Okay, so in LPT means both side lasers will go off. So in L-sync case also this will be off and this will be off. Okay, bit error case, I get bit error, I transparently transmit. This is the similar to the LPT off scenario. Now this case is the scenario LPT enabled, and the problem is between the section between the line cards. So all alarms remains the same at OTN layer, but if there is a problem, then if there is a problem in between, I will make it the laser off. Okay, at the same time I will send the BDI, but in terms of LPT, anywhere there is a problem, we need to make a rule that both side laser at the tributary boards will go down. So laser will be off here. So if any type of SF alarm will come, laser will go off both side, and further equipment will not get the L-sync because I will make the laser off. So it will only get the R loss. This scenario is where ALS enabled, LPT has to be disabled. So in case of ALS and LPT, the difference I told that it will take action only at the distant end. So if I get R loss here, definitely there will be remote SF and laser off. But this side laser trans will be still on. If so this ALS will not impact the site where I'm getting the alarm. When I make this laser off, and if this client equipment also is let's say having LPT, then this can make laser off this side. So then the sequence will be different, but let us not confuse ourselves. So if R loss is here, then there will be laser off this side, and L-sync here, laser off this side. Rest alarms will remain the same. Okay, so one more thing, sorry. So in case there is no power here, then only that laser will be off, but in case of L-sync there will not be any laser off at side B. So then this is the scenario of problem between the line boards. So laser off will be there, like if I get a SF alarm, the forward direction laser will be off. Okay, and in case of bit errors, no laser will be off. So this completes the scenarios of GFP-T framing, which is used in the network for 1G circuits. And thank you very much.